Let's talk about power management. Back in the old days of computers, we didn't think a whole lot about power management. When we powered the system on, everything used its allotment of power and used it all the time, whether or not the device was actually in use or not. Our hard drives kept spinning, our CPUs ran at full power, devices that were installed in expansion slots used their power even if they weren't in use. As time progressed, we saw that this was a problem. We could reduce the amount of power that a PC system consumed significantly by shutting off devices that weren't in use, turning them on when we needed them, when we were done, turning them back off. This is especially true with notebook systems, where power is a premium. We don't want to use any power that we don't have to when we're running off of batteries. To provide some means of managing power within our PC systems, two specifications have been used over the years: APM and ACPI. The problem with APM and ACPI is that folks tend to lump them together, even though they actually are two different things. And so folks will use the terms interchangeably. Let's talk about what the difference is between the two. And you'll see that nowadays, when someone says APM, usually what they're really talking about is ACPI. APM stands for Advanced Power Management. With APM, we introduce power management functionality into the system BIOS. Little software programs that run there that decide when a device needs to be turned off. Basically, the whole function or concept of APM is based on timeouts. In essence, how long has it been since somebody wrote something to the hard drive? If it's been over a specified amount of time, then let's turn off the hard drive. Works that way for all the devices that are managed by APM. APM has some problems. First of all, the OS and the BIOS don't communicate about what's going on. The OS doesn't know that the BIOS just shut off the hard disk drive, and that can cause problems. In addition, the APM standard wasn't very strict. That means that every BIOS manufacturer implemented APM in a different way, and so you had a wide range of APM implementations, none of them really functioning or working in the same way. To correct the problems associated with APM, a new standard has been introduced called the Advanced Configuration and Power Interface, or ACPI. This standard was created by Intel, Microsoft, and Toshiba, and it should replace APM, although, as I said before, most people use the two terms interchangeably. The ACPI specification specifies how a computer's BIOS, operating system, and devices all communicate with each other about power usage. In other words, the OS and the BIOS work together. The BIOS isn't shutting off devices that the OS needs. The two communicate and decide, okay, this is what we need to do. In order to implement ACPI, you have to have an ACPI compliant BIOS, and you have to have an ACP compliant OS. Which OSs are ACPI compliant? Anything in the Windows family from Windows 98 on are all ACPI compliant. In addition, most Linux distributions are also ACPI compliant. The way it works, let's suppose we have a PC system here. We have several different expansion cards installed in our expansion bus. We have our CPU, and we have our hard disk drives. Over here we have our BIOS. Over here we have our operating system. What happens is that the ACPI functionality within the BIOS monitors these different devices, the hard disk, the expansion ports, the CPU, and gathers information about how much power they're consuming. The BIOS then feeds that data to the operating system, which then decides how much power each of these different devices needs. If nothing's been going on with the hard disk for a long time, the operating system may say, spin down the hard disk drive, let's save some power. If we're dealing with a notebook system that's running on battery power, the operating system may say, you know what? We could really save a lot of power by slowing down the CPU. Let's do that. In addition, we're not using these two expansion devices, so let's shut them off until we need them as well. If something were to happen, say we all of a sudden an application running on the system says, I need to send information out through this particular interface card, then the operating system will start that device up, provide it with the power it needs so that it can service the request. If you've used Windows at all, especially if you've used Windows on a notebook PC system, then you've used ACPI functionality. For example, with ACPI, the user can specify at what time a device such as the monitor is to be turned off. You say after 30 minutes, turn the monitor off. After an hour, spin down the hard disk drives. In addition, with ACPI, the operating system can lower the clock speed of the CPU itself during times when applications really don't need the full CPU clock speed. The operating system can also reduce the motherboard and peripheral device power needs by not activating devices until you're needed. One of the problems with APM was the fact that it did not support plug-and-play devices. Well, in a modern PC system, most of what we use are plug-and-play devices, right? Therefore, the ACPI standard was written to support plug-and-play. As soon as a plug-and-play device is plugged in, it can be monitored and controlled by ACPI. Now, ACPI defines several different power states. The first ACPI state we need to be aware of is on. In the on state, basically, all power management functions are off. All devices, the CPU, the hard disk drive, peripherals, everything's running at full power. No power management is taking place. The next state is enabled. In the enabled state, power management is turned on, but no devices are shut down. Everything's running at full power. The next ACPI state is called standby. During standby, the CPU is shut down. However, RAM retains its contents. In addition, all peripheral devices are also shut down. ACPI also defines another state that's similar to standby. It's called suspend. In suspend mode, everything in the PC is shut down. Hard disk, monitors, CPU, everything is shut down except for RAM. The only device in the motherboard that still has power is RAM, so the contents are retained. Everything else gets shut off. The last ACPI state is called hibernate. Hibernate is really cool. What we do in hibernate is we shut off everything in the PC, kind of like with suspend. However, we shut off RAM as well. We want to be able to retain the contents, however, so what we do is during hibernate, before the system is shut off, the contents of the CPU registers, as well as the contents of RAM, are both written out to a file on the hard disk drive. The system is then shut off. When the system is started back up, the file is read, the appropriate information is read back into the CPU registers, and the appropriate RAM contents are also read back in. So even though the system was completely off, it is as though it wasn't off. You're right back where you started from. By implementing ACPI, we can dramatically reduce the amount of power our PC systems consume, which is good for you when the power bill comes. It's also really good if you're using a portable system where every last minute of battery power is sacred. In this lesson, we talked about power management. We talked about the two different standards that have been used to implement power management in PC systems. We talked about APM, and we also talked about ACPI.